A very marvelous and very charming good morning. A hearty warm welcome to our distinguished speaker of the day, Professor H.K. Sejwani sir. Our special guest, Professor P.K. Aluwalia sir. He is the President IAPT. We are delighted to have Professor Rekha Ghorpade. She is the General Secretary IAPT. Professor Subhash Samanta, Professor C.K. Ghosh, our ex-officio President Dr. O.P. Sharma, our past President Professor V.P. Srivastav, past Vice President Shri R.K. Tiwari, and past Secretary Dr. M.S. Bhandari, and all the Executive Council member of Indian Association of Physics Teachers, Regional Council 1, present over here, and my dear participants. I am Poonam Jain, your host and the Executive Council member of Indian Association of Physics Teachers, Regional Council 1. Welcome you all for the workshop on investigatory physics projects using Arduino, organized by IAPT RC1. Before beginning with the formal session of the day, this is to inform you that this session is being recorded and streaming live on YouTube and Facebook. Also, there is an important announcement for the participants that kindly post your queries and questions related to the talk in the chat box so that our coordinator can consider them after the talk. Attendance link will be shared at the end of the session, which is mandatory to fill, and only then you will be entitled for the certificate. Attendance link will not be shared personally after the lecture. This is very important to note over here. So kindly fill it during the session only. All the participants are now kindly requested to mute their mics during the whole session for the smooth conduct of the session. Now, without further ado, I request Dr. Yogesh Kumar, the Secretary, Indian Association of Physics Teachers, Regional Council 1, for welcome address and introduce our participants about IAPT. Over to you, Yogesh sir.
Thank you, ma'am. Good morning, everyone. On the behalf of IAPT, I, Yogesh Kumar, Secretary, IAPT RC1, welcome our eminent speaker, Professor H.K. Sejwani. He's a part of IAPT organization and very well-known face among us. We are delighted with the presence of Professor P.K. Aluwalia, President IAPT, Professor Rekha Ghorpade, General Secretary IAPT, Professor Subhash Samanta, and other distinguished professors present here. I welcome faculty from Delhi University, NCERT, schools, college, universities like IITs, IISER, TIFR from different parts of India, members of IAPT, DSSTF, and all other participants. Also, a warm and extended welcome to each and everyone who is here to mark their presence in this wonderful event. Indian Association of Physics Teachers, a major and well-reputed organization established by late Dr. D.P. Khandelwal in the year 1984, has a local chapters in every state. IAPT RC1 is a chapter of IAPT for Delhi and Haryana. We organize various activities for the promotion of physics and physics education. In this pandemic COVID-19, we have successfully conducted many important lectures for school and colleges, teachers, and students. We appreciate your gesture. It is very generous of you to spare your valuable time with us. We are proud members of a family in which everyone is willing to share his knowledge and experience with others. So with these words, on the behalf of IAPT RC1, I welcome you all. Thank you so much.
Thank you, sir. Now, I request Dr. O.P. Sharma, ex-officio president, to introduce Professor Aluwalia and invite him to inaugurate the perennial series of Arduino workshop. Over to you, sir.
Thank you, Dr. Poonam. It's indeed my pleasure to introduce Professor P.K. Aluwalia, National President of Indian Association of Physics Teachers, who has recently taken over the charge. Professor P.K. Aluwalia was Professor of Physics. Dean, Planning and Teacher Matters at Himachal Pradesh Central University, Simla. Before this national president, he has also been the vice president of Indian Association of Physics Teachers for our zone. He has got a rich experience, teaching experience over a span of 4 decades. His primary research areas are theoretical condensed matter physics and physics education research. He has keen interest in promoting the experimentation and innovations in the teaching learning of physics. He has got more than 100 publications in national, international reputed journals. He has guided more than 18 PhD students in the field of his expertise area. He has also written a number of books on computational physics and use of computers in the computational physics laboratory. He has been involved in popularization of science through features and talks on radios of the past 3 decades. Professor Ahluwalia has been awarded Commonwealth Academic Fellowship at University of Edinburgh during 97-98. He was also awarded with Environmental Leadership Award 2017 by the Department of Simla. He has been awarded with Best Teachers and Academic Administrators by the Himachal Pradesh University in 2012. And recently he has taken over as the National President of the Indian Association of Physics Teachers. We are really thankful to you, sir, for sparing time to be with us on this occasion, which is a very important beginning of a series of the experimentation in physics. And we are going to organize this series for a longer time. This is the first one on Arduino, and I am told that there will be a series even on the Arduino also. And thereafter, we are planning to organize a series of experimental physics for the teachers of schools and colleges throughout the year. That is our plan. So we are really thankful to you. I welcome you on behalf of IAPT and also on my personal behalf that you could make it possible to participate and grace this occasion. Thank you very much. We are really thankful to you. Over to you, Dr. Poonam.
Thank you, sir. Now, I am privileged to invite Professor Ahluwalia, sir, for the inaugural lecture. Over to you, Ahluwalia, sir.
Thank you very much.
Sir, you have joined via 2 devices. So kindly mute one.
There is an echo actually.
Sir, you have connected via 2 devices. Kindly disconnect one of them. Or should I do it for you?
Am I audible?
Yes, sir, you are audible, but there is a lot of echo because of the 2 devices.
Okay, let me see. I'll check.
Can you use that earphones? I think that can help.
Sir, now try to
Am I audible now?
Yes, sir. Now it is fine. I have removed one device.
Okay.
Now it's fine.
Thank you. Okay. So thank you very much. And I'm very pleased to be part of this program. I'm very happy to welcome here in this program our honorable speaker, Professor Sehjwani. I am thankful to Ma'am Seema Watts for giving me an opportunity to come here and be part of it. I am grateful to Professor O.P. Sharma for the kind words which he spoke about me. And it's my first interaction with the IAPT RC1. And it's a matter of joy for me. And I believe that you being the leading regional council of Indian Association of Physics Teachers. I believe that you are setting some kind of standards for us. And I congratulate you on creating this wonderful program, which is the need of the hour. I hope uh, you all know that IAPT is trying to reach out to its stakeholders. And reaching out to the stakeholders means that we have to really be very, very active with innovative programs. And there are so many opportunities, waiting for us. I don't know whether I should use this term or not, thanks to COVID, that we are able to interact so often now. I think it was never before like that. We used to meet once in a while, and then we used to think that, okay, we have done one program, so that is enough for us. But in today's scenario, I think we can really go ahead with a reach out, which can be very, very meaningful and engaging. I'm using this term specifically. It's very engaging to use this kind of a platform to reach out to the audience. And IAPT has this duty that we must really try to reach out to not only just one set of audiences, but to all the audiences to which we cater. For example, we cater to schools, we cater to colleges, we cater to universities, we cater to research institutes also. Ours is a very open platform. Ours is a very open organization. And that's the best part of it. And I think by organizing this program on Arduino, what you have started doing is you have also started creating a big resource for the IAPT users to use this at leisure, because these programs can be recorded. And you know that, and something which gets recorded has a possibility of reusability. If I am not part of this program right now, for example, I think I can become part of it at my own convenience also. That's the biggest advantage which uh, this platform actually offers us. I have been trying to reach out to regional councils to really make a calendar of their programs. And I think you have started with your calendar, though you have not yet declared your calendar for the year. And I'm sure you are going to come out with that very soon. Um, I know that you have been one of the most active uh, regional councils of the IAPT. And I think because you sit in Delhi, Delhi being the heart of the country itself, please allow me to say that you have a responsibility also. Responsibility in the sense that you have closeness to very many resource persons, just like Professor Sehjwani, whom you can reach out, connect very conveniently, and design your programs. I have been hearing about this Arduino quite a bit. And I find that this program is so good. Rather, as people say, it is the backbone of Atal Tinkering Labs itself. Whenever people want to talk about Arduino, they always say, yes, this can be very easily implemented via the Atal Tinkering Labs. And they are a big resource which is being created around us in schools with so many facilities which nobody had even imagined, say, 5 years back. And Arduino is a platform which can really help create people do very many things at different levels of maturity. They can just come together, assemble things, and see that they are working. But they can also, scale the usability of this Arduino. And I'm sure this particular program by Professor Sehjwani will help us see all these things. And it is actually a kind of a platform which is open source. That's the beauty of it. There are no bindings on top of it. The people have started building very many labs around Arduino, not only for physics, but for electronics, digital electronics, robotics. So there are so many, windows this particular platform of Arduino actually opens for us. And I'm very happy that we are initiating this program now. And hopefully in future, sometimes, we may also have an Arduino competition. I hope you will agree with me that there can be an Arduino competition of the IAPT in which we can encourage people to come forward and we can give them some incentive also to be part of this kind of program.
I think there is a network problem, sir.
Yes, sir is not audible. Um, Something wrong with the network.
His screen is freezes.
I'll call him and I'll let you know, huh?
Sure, sure. Ma'am.
He's joining in 1 minute, right?
Okay, ma'am, no problem.
Meanwhile, I have an announcement to make for all the attendees that actually feedbacks helps to draw the crucial line in between the audience interest and what the audience is interested in. So kindly mail your suggestions to iaptrc1@gmail.com regarding this workshop and how can we improve it further. Kindly mail your suggestions to iaptrc1@gmail.com. Thank you.
Yes, sir has joined back. Sir, you are on mute.
Okay.
Yes.
So I am back with you. Sorry for
No
all that
problem.
which has happened. Because of snow in the last, few days, we have this kind of a problem which is happening. But I'm ready with the mobile. Don't worry about it. I will be there for all reasons. So
Yes.
as I was saying that this is a wonderful opportunity. I think we can have competition. So this is the first thing which I would like to desire, that this year we should also have an Arduino competition of the IAPT. And Ma'am Seema, I would like to really request you that you please take this initiative along with very dynamic members of IAPT RC1. I know Professor O.P. Sharma quite a bit. I also know Ma'am Poonam because I have seen your programs, ma'am. So I hope we will have a wonderful time as we progress with this 2-hour program. And I will be there with you. I wish you all the best for this program. I will be there for all the time. Don't worry. I will be very keen to participate in this. Thank you very much. And once again, I thank Professor Sehjwani for
Thank you very
accepting
much, sir.
this kind of a program. Thank you very much.
Thank you so much, sir. I'm very happy to have the words of appreciation from you, and very happy to know we are the fastest, or I should say, the one who has taken the initiative in the recent year in all the RCs. These words are very encouraging, sir. I hope we go beyond this and set another benchmark for all the RCs. Thank you, sir, for your encouraging words. And now I proceed. Our speaker, Professor Sejwani, needs no introduction as he is a part of IAPT RC1 organization and rendered his service to this organization from so long. But formally for today's talk, I request Dr. Seema Vats, the President IAPT RC1, to introduce our speaker of today's lecture. Over to you, ma'am.
Thank you so much, Poonam. So first, I would like to take this opportunity to express my deep regards to our chief guest, Professor P.K. Ahluwalia. Thanks so much, sir, for your inspirational speech. It has really motivated all of us to do something innovative in physics community. And when I think we can arrange a Arduino competition workshop in near future very soon. Thanks so much. Now it gives me immense pleasure to introduce our eminent speaker, Professor H.K. Sejwani, who is a former Dean Academics at IISc College of Engineering and Technology, Greater Noida. He has been awarded with the most prestigious Man of the Year Award 2001 from American Biographical Institute. He has also bagged several academic extracurricular activity medals. He has arranged various workshops on telescope, new practicals for CBSE curriculum, nanotechnology, and entrepreneurship camps for undergraduate and school students. His introduction will take a day long, but I would say one thing about him, that he's a genius in all respect, as he perseveres hard to learn new things with zest and apply them skillfully to physics and other fields. Arduino is one of his passion, which he has nurtured over the years, and developed various Arduino-based physics projects, which would help us in this perennial workshop. Hope all of you will enjoy and learn with this workshop. We welcome you, sir, and please enlighten us with your talk.
Thank you, Seemaji. First of all, I would like to thank Professor P.K. Ahluwalia for sparing his valuable time to join our series of lectures. My thanks are also to Dr. O.P. Sharma and Dr. V.P. Srivastava for continuously motivating me to innovate something. And I have selected this Arduino as the program which in which I have developed a large number of the experiments of physics. Of course, using the Arduino, we can do anything, large number of the things, as Professor Ahluwalia has pointed out. But I have concentrated myself on the experiments of the physics. I have developed nearly 18 experiments, and as said by Ahluwalia ji, thanks to COVID. The COVID has really provided us a time to develop certain things, certain innovative programs, and but I will not be able to show all these 18 experiments. One or two experiments are such which we have sent for the publication, and naturally, unless they are published, I will not be able to show those programs. However, I will try my best to at least introduce to you how to use these Arduino for developing large number of the programs. I am now sharing my screen. I am retired professor, but not tired, at Dr. H.K. Sejwani, and you can see the two parts of this screen. One part is the journal publication, journal poster, which was really designed marvelously by Dr. Singhal, and on the right hand side,
it was designed by Seema ma'am.
You can't see.
Seema ma'am. No, we are able to see.
Oh. On the right hand side, I have shown 11 experiments. 11 experiments. Let me close it. Yes. The first one is the blinking of the LED. Second one is variation of the resistance of the LDR. LDR is a light dependent resistance. And another is just a musical scale experiment in which I will be able to tell you how the various functions can be made. And this is one of the very basic and simple experiment. Then I'll show you how the DC motors can be made to rotate clockwise and anti-clockwise. We can also use this for developing for verifying the tangent law. Interference of the sound, interference of the light. We have been performing so many experiments, but we have not been performing any experiment on the interference of the sound wave. And then there is a resonance experiment is available in every lab, but I will be using a absolutely different method of the resonance experiment. Then the distance measurement using ultrasonic sensors. In one of the discussion with discussion in our executive committee, Professor V.P. Srivastava said that some experiments should be introduced which can use the ultrasonic, and I took that idea and developed this particular program, getting multiple variable voltages. They're using the different pins of the Arduino. Of course, I will be showing everything online. See, with the by giving one voltage at one particular point, we shall be able to get large the voltages at large number of the points and different voltages at the large number of the points, and we can use all those voltages for the different purposes by a single source of the voltage. And then we have developed a very beautiful experiment on the determination of the G by measuring the time period using the IR sensors and the LDR sensor. I'm using also one of the open source program that is called as the Terraterm, which automatically records whatever reading we are taking. We don't have to record on the paper, but it will be automatically recording the various values that we should get. We shall be determining these two experiments will be the most beautiful experiments which you will really enjoy. And then there is a measurement of the temperature and the humidity using the DHT11 sensor. Of course, this experiment as available online is not the experiment that I am using. I am using it for the different purposes. Okay, for determination of the velocity of the sound using this particular sensor. Naturally, whenever someone asks me, what are you doing nowadays, what you are doing, I tell them that I am doing some work on the Arduino. And another question comes to me, and that question is, what is Arduino? What it can do? I tell them that the Arduino is an open source electronics platform for engineers and non-engineers. The important thing is the non-engineers world. So that means this program can be used. This Arduino can be used by engineers, non-engineers, arts students, arts teachers, anyone. And it is such a simple program that after attending the series of these four series the lectures, they will be able to make any number of the projects. We have a hardware in this, and that hardware is a Arduino board, which can read inputs such as the light falling on a sensor, status of the button, whether the button is on or off, detect the motion of a body nearer to this device, rotate the motor in the clockwise direction, anti-clockwise direction, activate a motor, turn the LED on, turn the LED off, and then read the variation of the resistances of the LDR, read potential from the potentiometer. Here I am using the word potential and not the potential difference. There will be a difference in the potential and potential difference, and I will explain at the when the time comes. Yeah, where we shall be using. Measure the distance of an object using waves and take an appropriate action. Detect an obstacle using the IR sensor. Can measure the temperature and humidity. In fact, imagination is the limit to its application. However, I shall limit my presentation to the experiments on the physics. To begin, we will see and understand. We will be using some devices and some components which we must understand before we are able to develop some program, and before we are able to understand few programs and how do we make the programs. And those things are Arduino board, breadboard, USB cable to connect the Arduino, various sensors, LEDs, resistances, basic principles of the sensors. Of course, today, because of the lack of the time, and because so many things have to be understood to how to make a program in the using the Arduino, I'll not be taking up this principles of the sensors. This I will be taking up in the next lecture if given the opportunity. So I am now explaining various components which we shall be using for Arduino, for making the programs of the Arduino. First thing to understand is the Arduino board. Here you can see the Arduino board. In this Arduino board, you can see that from this point, yes. You can see that there are certain pins, pin 0, 1, 2, 3, 4, 5, up to 13 pins. All these pins are called as the digital pins. These pins are called as the digital pins. And in these digital pins, digital means always 0 or 1. Either you will be getting high or you will be getting low. High means larger voltage. It will be 1, and low means 0. Digital will always work only with the 0 and 1. Once we say that this pin is high, that means this pin is 1. And in this program, we shall be using 5 volt of the voltage. And therefore, whenever we say that this is high, this pin is high, it means this pin has 5 volts. Whenever I say this pin is low, that means the pin has a 0 voltage here. So you can make this high and this as low, this as high and this as low. Any point, any pin you can make at high and you can make as low. High will always mean that you will be getting 5 volt here, and low means you will be getting the 0 voltage here. But you can see that there are the different symbols are. So this type of the symbol, caret symbol, is there at the pin number 3, 5, 6, 9, 10, and 11. 3, 5, 6, 9, 10, and 11. These points are having the special symbol, and these are the PWM pins. That is, PWM stands for the pulse width modulation. Of course, this pulse with the actual working of this pulse width modulation will be done in the successive programs Of course, we shall not be able to do everything today. On this side, there are digital pins, but on this side, there are analog pins. You can see here there are analog pins. This is A0 to A5, but this A0 to A5 is only in the Arduino Uno. There are various types of the boards, Arduino boards, in which there may be more than six analog pins. There may be 10 analog pins. There may be 8 analog pins, and so on and so forth. Whatever that depends upon the designing upon the board. So these are the analog pin, and analog means continuously varying. There you can have the value 1.1, 1.2, 1.3. Here you cannot take 1.1, 1.2, 1.3, except for those pins which are the PW pins. At all other points, you will be getting either 0 or you will be getting 1. Then there is a crystal here. This crystal is 16 megahertz crystal. 16 megahertz means 16 into 10 to the power 6, and this is producing this much cycles of the operation, and with each cycle one instruction is executed. What are the instructions? That you will again understand after some time. So for every instruction, there will be 1 over 16 into 10 to the power 6 seconds. That means when this a microsecond time is required for executing one instruction. This is the brain. This part is a brain. This is at Mega 328 microcontroller. So there is a confusion sometimes between the microcontroller and microprocessor. Here we are using the microcontroller and not the microprocessors. Microprocessors are the large processors which can do large number of the things. But if some experiment is to be done, or some device is to be made, then for a particular type of the operation, you don't need the microprocessor. You need only the microcontroller. These are used for the microcontrollers are used for executing only one type of the program at one time. Now on this point, from this point to this point, there are again more pins. Then those pins are V in, that is not required today. Then there are 2 ground pins here, and then 5 volt and 3.3 volts. Till last year, of course, all the devices which are used were using the 5 volt as the standard voltage. But nowadays, large number of the devices are using the 3.3 volt as the standard voltage. Of course, we shall be using, in this particular experiment, we shall be using only the 5 volt as the voltage for operating our devices. Then comes the breadboard. This breadboard, you can see that there are horizontal lines and there are vertical lines. On the horizontal lines, from this point to this point, all the pins are connected to each other. From this point to this point, all the pins are connected to each other. That means horizontal lines, all the pins in the horizontal lines are connected to each other. All the pins on this horizontal lines are connected to each other, but the pins, this and this vertical pins, are not connected to each other on this horizontal part. Similarly, here from this point to this point, and from this point to this point, all the pins are connected to each other. But this point and this point are not connected. Here I have shown a connection with the help of a simple connecting wire. I have connected this point with this point. This means that from this point to this point, all the points are connected. From this point to this point, all the points are connected, but this point and this point are not connected. In the vertical pins, all the vertical pins are connected. These vertical pins are connected. These vertical pins are connected. But this pin is not connected to this. That means all the in the horizontal part, this part and this part, the horizontal pins are the vertical pins are connected to each other, but the horizontal pins are not connected to each other, so that we are able to make large number of the circuits for the prototype projects. Then comes the various types of the USB cable. This is a USB cable, and this part of the USB cable is connected to our laptop or the computer, and this part is connected to the Arduino board, which of course I will be showing you later on. Then various types of the sensors are there. Of course, this is not a sensor. This is some program using the button. But this is a sensor DHT11 about which I just talked, and I'll be using it with a definite physics experiment. This is an IR sensor, infrared sensor. This is an ultrasonic device. This is a Bluetooth sensor. This is LDR. Of course, we shall be making use of it for two experiments. This is the light dependent resistance, on which whenever the light falls, its resistance decreases. When the light is not falling, its resistance increases. So this will be sensing the light. Then there are rheostat types of the devices called as the potentiometer. This is a small rheostat with 3 pins, 1 pin, 1 pin, and 1 pin. This is a potentiometer, 10K potentiometer. Of course, 1K potentiometer, 10K potentiometer, 1 mega potentiometer are all available in the market. And depending upon your requirement of the experiment, or depending upon your requirement of the device, you can make use of this potentiometer. You have seen the rheostat. In this rheostat, then the lower part, and suppose there is a rheostat, and the wire is wound over a cylinder. Then one end of the wire is connected to some terminal at the lower bottom, and another end of the wire is also connected at the bottom. And then there we have a moving object, which is, so this point, and this point are given some voltage. But at this point and this point, say 5 volt here, or 0 volt here, or 5 volt here is 0 volt here, and then the variation is done from this, and the variation is done with the help of some screwdriver using this. So this pin, the central pin, that will be measuring the Arduino will be measuring the potential at this particular pin. Arduino will be measuring. I am again showing and telling that Arduino will be measuring the potential at this particular point, and not the potential difference. Similarly, Arduino will be measuring the potential at this point and not the potential difference. But we know that since we are using the 5 volt device, out of which one is ground and another is 5 volt. So we already know that this point, if we have connected this point to the ground, then we already know that it is a 0 voltage, and then the potential it is at 0 potential, and this point will be at some potential which will be read by Arduino. If the Arduino reads that this is 2 volts, and we already know that this is 0 volt, then potential difference is naturally 2 minus 0 is equal to 2 volt, and this is 5 volt, this is 2 volt, so potential difference between this point and this point will be 3 volts. So important thing is that Arduino will not be measuring the potential difference. It will be measuring the potential. In fact, Arduino only senses the voltage signals and not any other signal. Then there are some jumper wires. These wires will be used to make the prototype devices, and by using the breadboard and the Arduino board. These are three types of the jumper wires are there. One is the male wire, another is the female wire, female jumper wire, and another one is the male-female wire, male-female wires. Then there are various types of the motors, stepper motors, servo motors, etc., which we shall not be using in this particular series. But then later on, for engineers and for others, this type of motors can be used. I'm skipping over the what are sensors because we need sufficient time to explain how to make the program. Now you see that softwares are always required for making anything, that is any program. Python is used for making so many programs, but Python is a software. Using that software, we are making certain programs which do so many things for us. For example, we can use them for developing the website. We can use them for doing some complicated mathematics. We can use them for so large number of the purposes. So for making certain program, you need a software to run that particular program. We shall also be using some software to develop certain programs, and that I am now using. We'll be using the Arduino IDE, Integrated Development Environment, as the software. Be making certain programs, and that first program that we shall be doing is the 3D three LEDs blinking. But we must understand that how do we download this so I am just clicking on it. You can see I have given the URL of the program from which of the site from which we can download our Arduino software, and using that software we shall be able to develop certain programs. So I have already given this link in my presentation. So I'm just clicking it out. Or what you can do is, what you should go to the some browser and type www.arduino.cc, and you will be reaching the same page on which I shall be reaching. So I'm just clicking it. As soon as I click, I reach a page. I reach a page on which there are so many things which are written: hardware, software, cloud, documentation, community, blog, and this. But today we shall be using the since we are interested in downloading the software. Therefore, I go to the software and click on it. As soon as I click on this, what I get is this screen. On this screen, of course, you can see on this side. I will again. Okay. On this side, you can see that there are three major operating systems. That is, one is the Windows operating system, Linux operating system, and the Mac operating system. Depending upon what type of the you are using in your own say laptop or the desktop, you can download any of these three. Since most of the people are using the Windows, therefore they can download Windows. But if there are some people are using the Mac, they can definitely download the Mac and then they can install. Since I have only the Windows on my system, Therefore, I'll be downloading the Windows. You can see here Windows Win 7 and newer. That means minimum requirement is Windows 7 on your laptop or desktop, and then anything above that version, which I'm now clicking on this. When I click on the Windows 7, again another screen comes, and there is a support the Arduino IDE. Yeah, it is written $3, $5, $10, $25, $50, and others. But then there are two things here: contribute and download, and then just download. In fact, this is an open source software, and large number of the people are working on this software. There naturally some resources or some money is required to develop the various components which are utilized, and there are a lot of research is being done on that. Therefore, it is desirable that we give them we support the Arduino IDE by donating $3, $5, etc. But it is not necessary at all. You can just download it without contributing, and I will be just downloading it. Although I have already installed the IDE, yet I will be doing it because it requires only few seconds to download, or 1 or 2 minutes. That is very much desirable today, because I will be explaining each and everything to you. I just download it. It comes to the Arduino 1.8.13 Windows. It is asking, there is my directory is there, data D directory. In that there is a download directory. In this download directory, I'll be downloading this. So just I save it. I just remove this, and you can see here that the Arduino 1.8.19 this is being downloaded. It has been downloaded by now. Okay, so you can see that it is the downloaded. So I click on this. As soon as I click, I am asked whether do you want to allow this application to make changes to your device. You have to say yes. If you say no, then of course this software will not be installed on your computer or the laptop. I say yes. Once I say yes, it is telling me that Arduino version 1.8.19 is already installed and must be uninstalled before. So I say yes, because I will be uninstalling this software and then reinstalling this software, and it will not take more than 1.5 minutes. So I just say okay. When I say okay, it will be again there is an uninstall here. I will uninstall. It says it is giving me the warning that all the existing files in this directory will be deleted. I am not bothered about it, because I do not keep any of my programs in this particular directory. It is desirable and it is advisable that whenever you install any software in any particular directory, do not keep your programs in that directory. Make another directory and you keep those programs in that directory. I say okay, because I'm not bothered. So my program is being uninstalled, and it will be uninstalled within few seconds. You can see that this is working, and so it is okay. Then I say okay, and once I say okay and I close it, again I am asked to agree to certain terms. Whenever you want to install anything, you have to agree to whatever they ask. Otherwise, it will not be installed. I agree. And then it is asking, which of the features you want to install. I want to install all the features of this, and I say next, and then I say install. Once I say install, it will take me, and on my laptop, it will take me 1 minute and 20 seconds. 20 seconds, as I have already experimented on this. So it is being installed, and you can see that that it is going very fast, and it will reach this particular point. This is a progress of what is happening. So once it is there, it has been completed. It shows that it has been completed, and then I say I close it now. So my Arduino IDE has been installed, but before going to the next part, I will suggest you to go to this documentation also. On this documentation, there is something called as the reference, and you must click it, and then whatever I advise you, kindly do it. So this is a reference. I have clicked on this, and then we have got a page. We have got page, and corresponding to this page we see language, that the functions, variables, structures, libraries, etc., etc. But I will show you something only. Say functions here. So there are input. I told you that there are various types of the pins. One is the digital pins, another are the analog pins. In the analog pins, we are reading something, we are writing something. On the digital pins, we are writing down something, or we are reading something. You see digital read. There is a definite way in which this definite read is written, and there is a opening bracket and closing bracket. Wherever after any word, the closing bracket and the starting bracket and the closing bracket are given, that is always considered as a function. Absolutely. ABS, this is a function. Random, this is a function. Pin mode is a function. And you see that these are the reserved word. Digital read is a reserved word. Digital write is a reserved word. This is max is a reserved word. Map is a reserved word. Okay? So we cannot use in our program the reserved word, which I will show you also while discussing the program. Then analog. What you can do here is, these are the only few functions and the variables which we can use in the which we'll be able to use in this particular program. And therefore you simply do one thing: type Control A, everything will be selected. Type Control C, everything will be copied. Open a Word file and paste that on the Word file, and then save that. That Word file you will be able to use for learning any function or any variable, and knowing whether a particular name that you are writing down is a reserved word or not. Now I just go to my oh where is the meeting? I'll again share. I'm sorry.
No problem, sir.
Yes. This you have done. Now I come to the actual program, my first program, which is the blinking of the LEDs and 3 LEDs. So I will take the laser pointer to show each and everything. First of all, I will explain to you this diagram, and then I will show you the working of the D3 LED on my on the screen. See, you can see that we have two things. One is this breadboard, another is your Arduino board, and on this Arduino board, as I've already told you, that there are digital pins on this side and analog pins on this side. The 3 LED program does not use the analog pins. It uses only the digital pins. In this, what I have done is there is a 5 volt pin here, and there is one ground pin here. I have taken ground pin and then connected to this particular line. So whole of this line is our negative. Similarly, 5 volt line I have connected to this point. So whole of this line is now positive. And then I have taken 3 resistances and 3 LEDs. Since we are using the 3 LEDs, therefore I have taken 3 LEDs. One LED is a red LED, another LED is our yellow LED, and the third LED is our green LED. And we have taken 3 resistances also. This is each is 220 ohms, but it is not necessary to take all these 3 resistances as 220 ohms. You can use any value between 150 ohms to 300 ohms for these resistances. But why these resistances are required? It is because the LEDs that we are using here, if you connect them directly to the 5 volts, then they will burn out. They will be damaged. Therefore, some limited current has to be passed through this, and that we can do by dropping some voltage across a resistance. This resistance and this LED are connected in series with each other, and therefore some part of the voltage is dropped across this, and remaining part of the voltage comes across this. So therefore, the limited current will be passing, and our LEDs will not be damaged. Now, one end of each resistance is connected to this negative line. This is a negative line. One end of each is connected to this. Another end of one of the LED, say this LED, Another end of this is connected to the negative of the LED, and then positive of the LED is connected to the pin number 8. I will show you very soon. Then similarly, for the red, one end is connected to the negative, second end is connected to the negative of the yellow, and the third positive of the LED is connected to the pin number 9, and similarly for this, it is connected to the pin number 10. Now, this will not work unless, of course, the program that we shall be writing that program that I shall be explaining is loaded on this Atmega 328P. We shall be asking it to blink, and for asking it to blink, we will be making some program. That program has to be loaded into this microcontroller. This is a microcontroller which I told you that it is Atmega 328P. I will now, on my laptop, I have two say devices which will take the two cameras. One is the camera of my laptop, and another is a webcam labra and the webcam. So I'll be just unsharing my screen, and then I will show you with the help of another camera. I'm now using the different camera. I'll be using the webcam to show that now this and I am just unsharing, stop sharing here. Yes. Now once I stop sharing, you can see my device here. This is your breadboard, and this is your Arduino board. Are you able to see?
Yes, sir, it is perfectly visible.
Okay. Thank you so much. Now you can see that there are three resistances here. There are three resistances. One resistance this, another resistance this, and another resistance this. This resistance is connected to the red LED, and then this resistance is connected to the yellow LED, and this resistance is connected to the green LED. And then what is happening is that this I have connected to the pin number 8. This is pin number 8. This is pin number 9, and this is pin number 10. So red wire I have connected to the pin number 8. Yellow wire I have connected to the pin number 9, and green wire I have connected to the pin number 10. And this is the black wire. Black wire is connected to the ground. This is connected to the ground because we need one ground. We need yellow, red, and green, and then of course what you can see on this side, this one. These are the other devices which we are not using on breadboard. They are lying just now. Now this is not working at the moment because I have not given it connected to my computer. I will connect it to my computer. As soon as I connect it to my computer, already some program which I have made is loaded into the Atmega 328P. Since I have already loaded it, therefore, as soon as I provided the power, then it will start operating. Let us see what it is doing. I'm just connecting this to my laptop, and you can see that now the light is there. And you can see that currently this red light is on. It will be on for 15 seconds. Then yellow light was on for the 2 seconds, and the green light will be on for 15 seconds. You can check it with your watch. Perhaps it is 10 seconds. This is 2 seconds, and then this is again 10 seconds. I will see what is there in the program because I just changed this program yesterday. So first red, then yellow, then green, then again yellow. Let it come. Yes, yellow for 2 seconds, and then this is the red. This is happening. We'll be using this logic in our program. So let me again share my screen. And change the change my camera to my integrated camera. I again share. Yes. Now, before going to the actual program, let me show you something more. This red line, any point on this line is not connected to any other point. That means this line is not required. For this particular experiment, we do not require the 5 volt from here, because 5 volt will be available from this point, and this point. This is what you must understand. And then so even if I remove this, it will be working exactly same. Now I'll be showing you the program. I'm clicking on it, and it is asking me to show you the program. The program, the Arduino IDE is being loaded. And now we have this Arduino program here. In this Arduino program, we have defined certain things. See, we are using 3 LEDs. Therefore, corresponding to each LED, which will be connected to pin number 8 or pin number 9 or pin number 10, it is not necessary for you to connect it to the pin number 8, 9 and 10. You can write down 5, 6 and 7. But if you write down 5, 6 and 7 in the program, then the pins in the which I showed you on the breadboard, they should be connected to the pin number 5, 6 and 7, whatever you want. So since I have connected my pins to the pin number 8, pin number 9 and pin number 10. Therefore, I define three variables. These variables have been named LEDR is equal to 8. So it is since it will be an integer, since pin is always integer. Pin cannot be 6.7, pin cannot be 6.8, pin has to be 1, 2, 3, 4, 5, 6, 7. Therefore, it is an integer type of the variable, and that integer variable, you have to write down int. This tell you what type of the variable you are defining. And LEDR, you can give it any name. I have written LEDR because it makes sense for me that we are using LED, and that LED is our red. You can actually write down RED. Then with whatever variable you will be using here, that you will be using in the program also. So I have written LEDR. LEDR is a variable name which has been assigned to pin number 8. LEDY, yellow, Y for yellow, has been assigned to pin number 9. LED green, G green, has been assigned to pin number 10. Then as you saw that red light was on for 10 seconds, green light was on for 10 seconds, and the yellow light was on for 2 seconds. This is, so we have defined, we want the red light to be on for some time, yellow light to be on for some time, and green light to be on for some time. Therefore, what we have to do? We have to define 3 variables, for which, say, del R. Del R means is a variable which is given the value 10,000. And below you will see delay R. Delay is a function. Delay and bracket, opening bracket, closing bracket is a function with something into it. This is some parameter. Parameter is our del R, the variable that we have defined, del R. And what value have we have given to this? We have given to this the value 10,000. So whatever is written here, that milliseconds time, the program will be delayed. That means program will be stopped for that much amount of the milliseconds of the time. So 10,000 seconds means I have written delay 10,000 here, and 10,000 milliseconds means 10 seconds. Therefore, these three variables will help us in controlling the time for which the red light will be on, for which the yellow light will be on, for which the green light will be on or off. See, then I come to, for any Arduino program, you have to have two functions. Minimum two functions are required. One function is called as the setup function. Another function is called as the loop function. Setup function, in setup function, we have to set up certain things. Since we are using only the LEDs in this particular program, therefore we are using them on certain pins, so we have to define the mode of the pin. It can be input it can be input or it can be output. But any pin can be input or any pin can be output. But you have to see what is the what you have to how do you have to assign the pins. What will be done by the LEDs? Let us think. They will be giving us the light. So we shall be getting output from the LEDs, and therefore pin mode for the LED R means red LED, which is given the number 8. So LED R is 8, and this output. Pin mode LED R is output. Pin mode LED Y will also be output because it will also be giving us the light. And LED G, the pin mode of the green, will also be output because it will also be giving us the light. We are not using anything else here. Therefore, there are 3 LEDs connected to 3 pins, and those 3 pins are given some mode, that is pin mode, this one. Now a loop. You saw that first of all the red light was on, then yellow light was on, then green light was on, then again the yellow light was on, and then green light was on. So once this particular thing is in our mind, then we can write a program in a loop, sir. Looping means program will start from the first instruction and will come to the last instruction, and then again start from the first function. So what we are doing? For writing the program, we have to give a thought. What do we want to do? We want to use the LED R. I am changing it now to I. We want that LED should be on. That means it should get full voltage. That is the high voltage. LED yellow should be off. LED green should be off. And low means 0. Low means 0. So high means on. Low means off. High is on and low is off. So we have made the red LED as on, then Y as off, and then green as off. And then once the red LED is on, we are saying that delay it for del R. That means for 10 seconds. We are asking it that red LED should continue to glow for a particular time, which is defined by this variable, that is for 10 seconds. As soon as 10 seconds are over, how does the computer know? How does it know that that 10 seconds are over? I told you that there is a inbuilt crystal, which is 16 megahertz crystal, and it is continuously giving us the pulses corresponding to which the programs are being executed. As soon as, and that crystal is now calculating the time interval for which it will be off. So it is the crystal which is controlling this time, and therefore, and since its least count is of the in microseconds, therefore the error in that particular time will almost be a negligible error. Then what we are doing second time, I want that the yellow should be high, yellow should be on, and red should be low, red should be off, green should be off. So it is off, it is the yellow is on, but for how long time? Delay del y. Del y we have given 200 milliseconds, therefore it is 2 seconds. So it will be on for 2 seconds. Then again comes the digital write. Then next time is the green. The red should be low, yellow should be low, and the green should be high. Green should be high. But for how long? For the time that we have given to the green. In our above, we have given this value as 10, this value as 10, and this value as 2. But it is not necessary. You can change the time for this green time and for the red time. It is not necessary to keep the time for the red as well as the green to be exactly the same. You can keep the different timings for different, and that is the beauty of this particular program. After the green is on, what should happen? Again, the yellow should come. So red is low, yellow is high, and green is low, and then there is a delay. So this is a simple program which is explaining to you how the loop will work and how the things will continue. Whatever is written in the setup, it is executed only once, but whatever is written in the void, it is executed one after the other. Now, once the program is written, it has to be verified whether there is any error in the program or not. And for that, you can see that it is verify, this is upload, this is new, this is our open, and this is our save. Whatever we shall be doing, whatever changes we shall be making, those changes have to be saved. You can see here LED 3 blinking is written, and there is this type of the symbol is there. As soon as I save it, that symbol is gone. So if you see something is there and you have not saved, you will be able to know from here, so that this program is now saved. But we have to verify that our program is right or not. So I just click on the verify. When I click on the verify, you can see that done compiling is done, and we have got we get some message in the white color. That means that our program is okay. Now you can see in the whole of this program, you can see that there is a semicolon at the end of each line. This semicolon, 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 semicolon. Everywhere you will find out that for every line there is a semicolon here. What happens if we forget to write down the semicolon? So I just remove this semicolon and try to verify the program. I just try to verify the program. Oh, you can see that something red has come here, and it is written here. It is written here, expected, comma, or semicolon before INT. You can see that this is a red line. Whole of this has become red, and INT is written here. INT is written here, and it is saying that it is expected to have the comma or semicolon before the INT. Before INT is this, and therefore we have removed this semicolon. Therefore, if we put the semicolon here and verify again, we will see that this again, there is no problem in this. Now let me do some other mistake in this. I am writing down here a small r. Instead of small r, I write down the capital R. This is the variable defined by me. Once I have defined LED R, everywhere else I have written LED small r, LED small r, LED small r, but I am now changing this LED small r to capital R. See what happens if I verify. Oh, wrong. On the line number 16, you can see that there is a red line. And what this is saying? LED small r was not declared. Here I have written LED small r. But in the declaration, I have changed the LED small r to LED capital R. So for Arduino and for the computers, and computers are not like human beings. Computers will do whatever they are told to do. So that is the difference between the human being and the machines. Although artificial intelligence is being used nowadays for detecting these type of the things, but in LED and this program, LED small r will be different from the LED capital R. Therefore, if I change and it is written that LED R was not defined. Yes, we have not defined LED small r. Therefore, what I do is I do this is small r again here, and then again verify it. I verify this program is perfectly okay. Then now you can see that pin mode is a reserved word of this program. This pin mode is a reserved word, and this is having a red color or orange color, whatever you can see. This is, I change this from E to capital E. Or I simply remove this E. You can see that this color was orange, but this color is black. Let me verify and let us see what does it say. Verify. Again it says pin mode MOD E is not there, was not declared in this scope. We have not declared because pin mode is not a reserved word, but pin MOD small e is a reserved word. Therefore, all the reserved words have to be used as they are. If I change this small p to capital P, if I change small p to say capital P, again there will be an error. This is, I just do it again. Pin mode was not declared. So that means whenever you get something red, something will be told to you what is the mistake that you have done. And that is the beauty of this IDE. So what I'm now doing is, I'll be again converting it to small p and then pin mode and then verify again. Verify. Just see, again there is a message in the white. Next thing, this output has to be written, every letter has to be written in capital. Every letter has to be written capital. Output, if I make one letter, say output with one letter as small t, then it is not a reserved word, and it has to be declared somewhere, which we have not done. So let us again there is an error. Output was not declared. So that means output has to be written with all the letters in capital. So what I do is now here is capital T. And then again verify this program. Again, it is completely okay. Now I do one thing. I told you that the high is 1 and low is 0. So I'm changing this high to 1. And let me see, high was a reserved word. And instead of using that reserved word, I have used 1. And since I have already told you that high will always be taken as 1, low will be taken as 0, and therefore I should not have any error if I do so. So what I do is I just verify. No error. You can see that there is absolutely absolutely no error if I change the high to. If I change this low to zero, and then again try to verify the program, you will see that again there is no error. That means it is taking high, all capital letters, low, all capital letters, to 1 and 0. For the sake of the simplicity, I will keep it as 1, or I can keep it. Let me keep it and then see. Once we have written a program, once we have found out what are the possible errors which can happen in this, we now just cannot load this program into our Arduino. See, if I remove I have showed you that I connected the lead and USB cable to my laptop, and I have just removed the cable from laptop, and I try to upload it. Before uploading, we have to do two more things. Let us see. We have to come to tools. In these tools, there is some board, and that board which I am using is the Arduino board. But then there has to be some port also. Communication is done through some port in our programs, and I just removed my device from the from my computer, and then therefore there was no port is visible here. But I will have to refresh it. Port is not coming. Port is still not coming. I may have to reload the program. Oh, yes. So I come to the tools, and you can now see that there is a port. Previously, port was not visible because my USB was not correctly connected, and this port is a COM9, and it is having the across my tick mark. There, that means the board is there, Arduino board is there, and the COM9 communication port is also there. Once these two things are there, then you can upload the program. We have not made any changes here. 10,000, 2,000, 10,000. We have not made any changes. But let me first of all upload it, and then see whether the program is running again or not. Done uploading, and then program is running. If I just remove my sharing, then you will be able to see that the program is running again. Oh, I will have to show change to webcam. Webcam is there, and I just, can you see this?
Yes, sir. Sir, can you explain how to run the program once again? There is a query.
Yes, I can. I will. Just let me share the screen again. Yes, this is the, I think I will have to connect my integrated camera, and then I will have to share this. Okay. What is the query?
You can repeat how to run the program once it's
Okay.
done.
Okay. See, for running the program, we have to make certain connections. And once we have made some connection, we have to upload that program on our microcontroller. Once the program is connected to the microcontroller, loaded on the microcontroller, it will automatically start working. So you don't have to give it any command to work. What you have to do is only you do the क्या कहते हैं, upload the program. So I will switch over from this my this क्या कहते हैं, this switch over from the normal camera to the webcam, and then I will show you what is happening. That is the most beautiful thing, and your question is very much valid. So you will understand it very beautifully once I change myself to the camera webcam. I'm changing to the webcam. Webcam is now on, and I stop the sharing. Now, is it visible?
Yes, sir.
Why it is not visible to me? Yes. Okay, it has taken some time. So 2-3 minutes will be fine for you to understand. I'm removing these lines. You can see that I have removed my cable also. I have removed the cable also. Everything I have removed. But you know that I have, before removing it, I have uploaded the program on this microcontroller. This is the brain of this. Everything is now on this. What I need now is to, since program is already there, I have to make some connections only. That's all. And in fact, without making any connection, you can make the program and upload it on this program. Now everything is here. What I shall be doing is I'll be taking this particular line to the ground. There is a ground point here. So I have connected to the ground point. Then as I told you that this line has to be made ground. So I have made this line as the ground. I have made this line as the ground. Whole of this line is ground, and these are the resistances which are connected to the ground. Now this point, this red has to be connected to what? This red has to be connected to pin number 8. I am just putting it here on the same line, because all the vertical points are connected to each other. Therefore, red negative is here, and I'll be connecting this point to the pin number 8. So this is pin number 8. Then I'll be taking this yellow wire, connecting it to this particular point, connecting it to this particular point, and then this point to the, as you must be remembering, it is connected to the point number 9, pin number 9, and then This is to be this point is green. Green. I am connecting it. Connecting it to the pin number 10. See this, I have made all the connections again before you. Now you know that program has already been loaded onto this. What we have to do to run this program, what we have to do is to give it the power supply. That's all. And power supply can be given in 3 ways. Number one is connect this USB port, your USB cable to your computer. This is one method. Second method is connect this journal cable and this 9 volt cable just like this. You can see this type of the devices there. And this is of course 12 volt, but it will be 9 volt regular power supply can always be used, and that can be connected to this point. That can be connected to this point. This is the second way. Third way is that there is a V in here. There is V in from this side. Yes, on this side, at this part, first pin is V in our input voltage. So you take a battery or 9 volt battery and connect the positive of that battery to this pin number, pin V in pin, and the negative to the ground. The ground is, there are 3 grounds. One ground is here and 2 grounds are here. So you take a battery, take connect one pin of the battery, the negative of the battery to the ground, and positive of the battery to the V in. All these 3 methods will be sufficient to run this program. I'll now be, since I have I don't have the special separate battery, 9 volt battery. Therefore, I'll be just connecting it to what? Connecting it to my laptop. And as soon as I connect it to my laptop, it will start working. It has started working. So running the program is not a problem. Making the program, checking the program, checking the true correct port and the correct board is the only problem. So I think if it is okay, please ask the person to say whether it is okay or not. Is it okay?
Yes, sir, it's fine.
Okay. So that of course finishes almost everything. But then let me share again. Let me change my to integrated camera. So I am now available on the integrated camera.
Sir, sorry for interrupting you. There is a question asked by Mr. Sen. What is the function of reset button on Uno?
Yes. Oh, very good question. Reset button is to stop everything. When the program is running, everything will be stopped, and the program will start from the very beginning. That means it will be interrupted wherever it is. Suppose yellow is running on, and you simply press the reset button. So what will happen is program will restart, and the red light will be on, then yellow light will be on, then green light will be on. It is a resetting on. Yes.
Yes, sir. Sir, the complete question is like you have used two objects on the breadboard. One is black in color and another one is gray in color, except that those LEDs. So Juhi Mishra want to ask, what is the use of those two?
Which one?
Sir, on the breadboard, there are two circular shaped button types of things.
These circular shaped buttons were not required at all. We are not using them. I just placed it so that they are not misplaced anywhere. Yeah, one is of course it's simply a button whose one program will be showing in the coming sessions, and this is a buzzer. This is a buzzer with the help of which we shall be producing some sound when object is at certain distance from the ultrasonic. When object is at certain distance from the ultrasonic, okay, this buzzer will be producing some sound. When the distance changes, it will be producing different sound, and when it further changes, they will be producing other sound. So they were only placed here because I did not want them to be misplaced.
Yes, sir. Actually, these two questions are directly related to the breadboard. That's why we have asked those. And now I would like to thank you for such an enlightening lecture. And it is pleasure to learn from you, sir, about the Arduino. Now, I request Dr. S.K. Singhal, the Treasurer IAPT RC1, to conduct the question answer session because I can see a lot of queries from the participant. So, sir,
Sure.
please take a few queries according to the time.
Sure,
Over
sure.
to you, sir.
Thank you, Poonam ma'am. And
Yes.
thank you, Sajwani sir, for this wonderful presentation.
Thank you
We
very much.
learn a lot from you always, and all the participants also learn many things. This Arduino in a very simple way. So some of the questions they are asking. One question that is the Venkata Mukherjee, he is saying how to delete the pre-uploaded program from the microcontroller.
See, we don't have to delete any program from the microcontroller. Otherwise, there are certain machines which can do that, but it is not required at all. If you want to write down another program, then simply upload that program, and the previous program will be gone.
Okay, sir. And another one, they were saying very good, wonderful session, nice session. Thanks. Just please the first slide will be given to all of you, and in the recording also we are giving. Learn many things, lot of excellent exploration they all are saying, and yes, I always wanted to learn, nice teaching, that's all. And I don't think any other question they are asking. Okay. Feedback.
No, sir.
Yeah, feedback form we are just giving. One is the question is here. Yes, this is the question in the chat. What happened every capital alphabet to the replace to small into a small alphabet? Output is into the okay, that already given the answer. She say Mrs. Ashish is saying what happened every capital alphabet to replace to small one.
See, the reserved word, they have to be used as they are, and that is why I told you that that in the reference you download that, copy that into the Word file, and if any small, all the small letters are capital letters are converted into small letters, it would be considered as a different thing. It will not be a reserved word. So reserved word are to be used as reserved word. Wherever there is a capital, it has to be capital. Wherever there is a small, it has to be small. Otherwise, it will ask. It will show you the error while checking the program. Yeah. So, and it will tell you where is the error. It will say that it has not been defined. Once it has not been defined, it has to be changed.
And Vivekanand is asking what is the function of PWM pins?
PWM pins, they are pulse width modulation pins. Okay. See, normally I told you that all the pins are the digital pins. Therefore, you get values only 0 and 1. But if you want to get say 1.2, 1.3, 1.4, etc., then you have to use the PWM pins. For corresponding to this, we shall be say showing you a program in the next series of the session.
Thank you, sir. One more question that is given. How can we minimize the filter? Sir, he's saying the filters smoothen the noise, but I am surprising certain desirable trend of my output. So my question is, how can we minimize the noise?
Which noise? Which noise? It is that is a software
Noise
problem
appearing in the serial monitor.
Appearing in the serial monitor.
Yes.
So serial monitor, we have we don't have anything to decrease the noise. Okay? Serial monitor we have not used today. Also, serial monitor we will be getting only whatever we want to print, or whatever we want to input. Okay? But there is no method of decreasing the noise. Noise is a basic software problem of the Zoom or of any other device. But this type of noise is not removed in
Kirtana is asking what is the difference between the digital and analog pins.
In digital pin, I already told you that digital pins we will give you 10 10 10 except for the PWM pins. For the PWM pins, we have to write down a program so that we are able to get the float values. But analog pins are the analog. Analog means continuous variation, just as you see in galvanometers or you voltmeters and the ammeters, etc. Whenever you change the value, say change the resistance with the help of the rheostat. What happens is the pointer moves, okay? And pointer can move anywhere. So you can get and the continuously varying values in the analog pins and 0 and 1 in the digital pins.
Dev Malya is asking, is there any sample for basic operation of the different sensor and programs?
What is this?
Is there any sample for basic operation of different sensors and programs?
See, there are large number of the examples already given because since the time was very short, therefore I did not show you the various examples which are already given in this Arduino IDE. And next time when I start with this next series of the programs, I will tell you how the inbuilt examples can be used. And this is a wonderful thing that which everyone should to start with. One should use those examples. I will also tell something about the say what is that CAD. This is called as a Tinkercad. I will also give something about the Tinkercad, with the help of which whatever program we have discussed today, we will be able to show on the Tinkercad. It's a wonderful device. I have already tested all these programs which I have made on the Tinkercad also. Yes. So they will learn a lot of things from in the next lecture, in which I'll be using a few of these things.
So last question, Neeta Sikri is asking, how to decide which pin is to be used, analog or digital?
See, that is what I told you, that if something is giving you the output, then it has to be output. While setting up in the setup, it has to be. For example, if you are using the rheostat, in the rheostat, you will be reading something. So when you read something, it is something input to you. And any pin can be used as the output pin. any pin can be used as a input pin. Say it can, but we have to make we have to make decision what we are going to do. If we want to read something, then we will call it as an input. If we want to, if something is giving us output, for example, when we run the motor, we run the motor is an output. Motion is being seen, and we have to, and if we want to change the speed of that motor, then we have to use the rheostat, and rheostat will be reading, and therefore it will be input. So any pin can be used. It is not necessary that 8, 9, 10 will be used. You can decide any pin except the pin number 1 and pin number 0 and pin number 1, which are the communication pin. I'm sorry, I forgot to tell about these communication pins, 0 pin and the 1 pin.
Thank you, sir. Still some questions are asking, but I think the time is too much. So I think they can send the question to you through mail. I'm just putting the mail of the Sejwani sir. I think, sir, it is okay. I can put
Sure. No problem.
So we are sending the mail, and also we are sending the the feedback form in the chat box. And now over to Poonam ma'am now. Thank you, Sejwani sir.
Thank you, sir. Thank you very much.
Sir, one query on behalf of all the participants. Can you please share the PPT to us so that we can share with the participants?
Sure. PPT, this PDF file of that PPT I can send.
Sure, sir. Sure. PDF is much better as compared to PPT to share.
I'll send you. I will send you. At your mail, I should send?
My mail? Yes, sir. You may send it on my email ID. And I will share with the participants.
Then you can share with them.
Sure, sir.
Everyone.
Sure.
Yes,
sure,
I have no problem at all.
Okay, sir. Thank you, sir.
Thank you very much.
Now at the end, I request Mr. Surjan Singh, the Vice President of IAPT RC1, to propose official vote of thanks. Over to you, sir.
Thank you, Poonam ma'am. Am I audible?
Yes, sir.
Okay. Very good afternoon to one and all present here. Honorable Professor P.K. Ahluwalia, President IAPT and National Body, Professor Rekha Ghorpade, General Secretary IAPT, Professor Suhas Samanta, Professor C.K. Ghosh, Dr. B.P. Tyagi, Dr. O.P. Sharma ji, and Dr. Seema Vats, President IAPT RC1 Delhi and Haryana. Our most valued invited guest, ladies and gentlemen, it's my privilege to have been asked to propose a vote of thanks for this great occasion, that is a webinar by Professor Sehjwani. I, Surjan Singh, Vice President IAPT RC1, Delhi and Haryana, on behalf of IAPT RC1 and entire team, and on my own behalf, extend a very hearty vote of thanks to all speakers for gracing your important work and sharing with us your valuable findings and researches. A big thank you to Professor P.K. Ahluwalia and Professor Rekha Ghorpade, who spared their very precious time and graced the webinar for their kind words and presence. I must mention my deep sense of appreciation for Professor H.K. Sehjwani, a renowned person in the field of physics, for his explanation of investigative physics projects using Arduino. He deserves the brilliant. He explained the projects brilliantly, and the projects which you have explained today, we really understood how the traffic light works. I think this circuit maybe is being used there because red, green, and yellow LEDs for a particular time. This circuit may be used there or might be being used, maybe using there. So we are able to know today itself. Sir, your experimentation, your explanation is wonderful. Just your explanation was just like your name, Sehjwani. Sehjwani, simple words. in simple words, you have explained how to make a project, how to make a program, and how to verify, how to upload on the microcontroller. This was amazing. So we really are grateful to you that you have given so vast knowledge to us, and you have explained all the things in nice words. You have explained different terminology, reserve words, output, input, digital physics, analog physics. Actually, those were the days when I was doing my MSc. At the time, we were having a microprocessor lab. So at that time, we were used to make the programs and to run them effectively. So after so many years, nearly 25, 26 years, today itself, I was recalling all those days when we were doing. So I am on personal behalf, I am very thankful to you, sir. I would like to take the opportunity to place on record our hearty thanks to our previous president, Professor V.P. Srivastava ji, Dr. O.P. Sharma ji, who have made tremendous contributions in IEPT RC1 for making it a great and successful organization, and who have set very high standards, benchmarks to achieve. I also extend my thanks to Mr. Mohan Bhandari, Mr. R.K. Tiwari, Mr. Jaivir Singh ji, Dr. Ravi Bhattacharya ji, Dr. R.S. Das, Mr. Ramni Kapoor ma'am, Mr. Rakesh Bharadwaj, and other members of previous Executive Council of IEPT RC1 for their innovative and valuable contributions in achieving the milestones and for their dedicated efforts. I would like to express my gratitude to our present President, Dr. Seema Vats, Associate Professor, for her innovative and constructive approach for organizing such a wonderful series of webinars. That is the physics projects on using Arduino. I think this platform is very, very useful to all the school students, all the college students. She has great vision for further to organize more and more purposeful programs for the benefits of the physics fraternity. An event like this cannot happen overnight. The wheels start rolling weeks ago. It requires proper planning and a bird's eye for details. We have been fortunate enough to be backed by a team of very motivated and dedicated members like Dr. Yogesh Kumar, Secretary IPT RC1, Dr. S.K. Singhal, Treasurer IPT RC1, Dr. Poonam Jain, Sehjwani sir itself, Dr. Ajay Garg, Dr. Manoj Kaushik, Mr. Vikas Mittal, who worked day and night under the visionary leadership of our President, Dr. Seema Vats. I thank you all these members for their result-oriented contribution in making this webinar a great success. At the last but not the least, I would like to express my gratitude for distinguished professors, faculty from Delhi and other universities, NCRTs, IITs, teachers from Delhi schools and the schools of other part of the country, members of Delhi School Science Teacher Forum, and Anvesika. I would like to express my thanks to Poonam Jain ma'am, because she is coordinating all the events very well. It is not possible to name all the participants who attended this wonderful webinar by Sehjwani sir. Therefore, thank you everyone once again for making this webinar a great success. Thank you very much. Over to you, ma'am.
Thank you.
Thank you, sir. Thank you so much for your kind words. Today's event, a resounding success, has approached its completion. Before signing off formally, I thank the speaker for enlightening the audience with his wide knowledge about physics project using Arduino. Heartfelt thanks to our special guest, Professor Ahluwalia. A heartfelt gratitude to all the other distinguished guests for evincing interest in the event and giving us their time. This event is not completed without mentioning a big thank you to our participants for making it a great success. There is an announcement for the participant. The attendance link is shared in the chat box. Please fill it right now. After the lecture, it is not shared on the personal basis. Thank you all for joining us. Thank you everyone for being a part of this lecture.
Can I say one word?
Yes, sir. Please, sir.
I am thankful to Professor Khare, who is here today also at my special request. I am developing a software with his guidance. I have been able to start making a software, and he has been guiding me since for the last 1 month. How difficult it is to implement the new education policy, and how difficult it is to make a software connected to that. I am really thankful to Professor Khare sir, who has given me the knowledge, and he is helping me to develop a wonderful software, which of course will take nearly 1 year, but then it will be of very useful for colleges, schools, and other institutions. My special thanks to Professor Avdesh Khare.
Welcome, sir. And now I would like Professor P.K. Ahluwalia, sir, to please give some concluding remarks on this lecture. Welcome, Khare, sir. It's a pleasure meeting you. P.K. Ahluwalia, sir, can you hear us? Yogesh, you can just check.
Ma'am, I think he is not in the meeting.
Okay.
I want to request Dr. Rekha Ghorpade. She is a secretary of IAPT.
No, she is in a meeting right now. So
Okay, she is
somebody.
Okay. Okay. Oh, no problem. I request all the other distinguished members would like to give some concluding remark on this workshop. Any remarks, any feedback for us for improvements? OP Sharma sir, Srivastav sir.
Sehjwani ji, it was excellent workshop.
Excellent
workshop.
Thank
for
you,
a
sir.
person like me, for a beginner, to understand the basics of Arduino and the components being used in that, I think it should be made available to all the physics teachers. They can start learning right from the basics, and then can go to the next level, whatever they want. So
Thank
this
you very much,
series is
sir.
going to be very, very useful and successful. And using this concept, I think what Professor Ahluwalia ji has suggested to start Arduino competition, this can be innovative use of Arduino for the experimentation, and also to find the solution to different problems of the society, like this problem of red light in the traffic control, traffic management has been very good use of Arduino and this whole concept. Similarly, there are many problems in society where this concept using the Python and Arduino can be done. So this kind of series and the experimentation and the training, and one I will discuss with you in detail. I heard one term that you have been organizing entrepreneurship camps also. So if that is right, then I think it can be very much linked with that entrepreneurial or innovation concept. I'm working now in this field of promoting innovation entrepreneurship in startup among these students of our university. So in that context also, the use of Arduino can be very much important. So that can be another dimension to this series. So every time you can highlight the innovative use of Arduino, though these all things are being used, but if you are suggesting some problems like one problem of traffic management at the red light, at the crossing, that has been sorted out. If similarly other problems are identified and their solutions are being tried out by the help of this kind of technology, then I think students can apply their mind also towards some new things, doing new thing for the society, solving out the problems of the society. So that way, very wonderful interactive session, and it will be good for all of us to learn. I think we should all start learning.
Thank you very much, sir. Thank you very much.
And you are really inspiration and motivation to all of us, that you have been utilizing all your time, all your talent, potential to the service of the
Sir,
people.
it is giving. It is keeping me young, sir.
Yes. Thank
Okay,
you. Thank you very much.
Thank you, sir.
I'll discuss with you in detail how we can go.
Correct, sir. Thank you very much.
Thank you, sir. Now, Professor Ahluwalia is among us now. So I would like to request Professor Ahluwalia, sir, to give some concluding remarks.
Thank you very much, Professor Yogesh. And I think I enjoyed it thoroughly. But for the two glitches which I had right in the beginning and later, this was perfect. Professor Sejwani, I think you have done a wonderful job today. And I think it is going to lead to not just one program, a series of programs. And this will be great because of a few things which are happening in the national education policy front also. Because there, people are looking forward to what kind of projects can be done, because there is a lot of emphasis on projects. Everybody is talking about if we have to really give projects, from where we should get. And I think you have shown us a platform today which can be used as a wonderful project platform for all stages: school, college, and university. And these can be developed into, good, innovative projects also. Something useful can come out of it. That is also something which students of physics normally actually just don't reach. So if we can really reach that kind of a stage where students of physics find that there is something worthwhile, useful can be done, and lots of things can be learned in this fashion through an interface of hardware and the software, that is, I think, the very, very timely thing which has happened. And I know, sir, let me tell you, and I know that you know that also, we have 22 regional councils. And once the word about this program spreads, maybe you will get more invitations from those councils also. So please do oblige them also with your
whatever I can do. I will do, sir, whatever I can, sir.
With whatever possibly you will be looking forward to. And I must thank the young team, very vibrant team, being carried ahead under the guidance of Professor V.P. Srivastava. I must really, sir, thank you for guiding this RC1, and your blessings should always be there, and I am sure they will remain there. Professor O.P. Sharma is a very innovative person. He has started talking about entrepreneurship already. I think these are the kinds of discussions and the ideas which must be propagated forward. I was just telling Ma'am Seema when she gave me a ring for this particular program, that now you being the president, and that is itself a wonderful thing. I think more and more women presidents should come in RCs, because then things will start moving much, much faster. पूनम जी, you are great. आपने बहुत अच्छा स्टेज भी संभाला, और I must thank Professor Sehjwani that he said, okay, he will give the PDF also to all the participants. And if the participants were nearing almost 100, that speaks of the success of this program itself. I think this is the kind of number which is needed for really reaching out to the people. बहुत बहुत आपको बधाई सबको, और मैं भविष्य में भी आप जब कभी प्रोग्राम करेंगे आप मुझे जरूर बताइएगा, मेरी आने की कोशिश पूरी रहेगी। और मैं ताली बजाने में सबसे आगे रहूंगा, ये भी मैं आपको बता देता हूँ, इसमें कोई कमी नहीं रखूंगा, क्योंकि आइडियाज बहुत अच्छे हैं और ये आइडियाज को दूर तक पहुंचाने की जरूरत है। तो एक बार फिर आपका बहुत बहुत धन्यवाद। प्रोफेसर ओपी शर्मा जी का भी बहुत बहुत धन्यवाद। उनके पास तो एक बहुत बड़ा प्लेटफॉर्म है जिससे वो आगे चीजों को पुश कर सकते हैं। तो आप मिल करके जिसको कहते हैं एवरीवन टुगेदर, इफ वी विल डू, आई थिंक वी विल डेफिनेटली मेक IAPT a very very vibrant organization, and we should feel proud of the fact that we are moving ahead in that particular direction itself. So thank you once again for inviting me, and I really enjoyed it thoroughly. Thank you very, very much.
Thank you very much.
Thank you, sir.
Ahluwalia ji.
Thank you, sir.
Thank you very much.
Thank you so much, sir.
Thank you, sir. Thank you.
Thank you, sir. Hoping for
Thank you,
each
sir.
and every lecture we will
you, sir.
invite you and you will give your eminent time, sir. Hoping for your time, sir.
Okay.
In
Thank
near
you, sir.
future.
Thank you very much, sir.
Thank you.
Now I would like to request Professor Srivastava sir to say something about this program.
Unmute
Sir,
कीजिए
you
sir.
are on
Sir,
mute.
unmute करिए please.
Well, it was a great experience sitting through this, listening to a lecture by Professor Sajwani. I'm sure we will get more chances. और मुझे सबसे ज़्यादा खुशी होगी कि जब हम फिजिकली मिल सकेंगे, और मैं रिक्वेस्ट ये करूँगा कि इस तरह का वर्कशॉप फिजिकली कराया जाए। 15-20 स्मॉल नंबर के पार्टिसिपेंट ले लिया जाए टीचर्स को, और सबको फैसिलिटी प्रोवाइड करके maybe we somehow arrange some 20 sets or 15 sets of small things, and their hands-on experience साथ ही कराया जाए वहाँ पर टीचर्स को, तब जाके उनको वर्किंग नॉलेज होगा, and they can carry their experience to their system, school, college or university, they can carry their system. So I am just looking forward to that opportunity or that workshop where we can arrange small things for, let us say, 10 or 20 or 15 participants, and then we run for 2-3 hours or 4 hours with a lunch break or tea break, so that teacher and students are practiced, or they are given their real-time experience, and they can carry over their experience to their system. So just I'm looking for physical things, and I'm very grateful to Sajwani sir that he has given time. Grateful to Professor Ahluwalia who has graced this occasion, and of course always grateful to, I should not mention, he is one of us, Dr. Upi Sharma, who has gave the strength to this organization. We are just carrying forward his flags, and our new president, I'm very sure it is a very good beginning for us. And she says, I mean, as Professor Ahluwalia mentioned, this is a Nari Shakti. So physicist with plus a Nari Shakti, together we will do wonders. Thank you very much, everyone.
Thank you, sir.
Thank you, sir. Yes,
Thank
sir,
you, sir.
it's a very nice suggestion. If we can have the hands-on practice, half-day session or so, then it is a very good chance for the participants to understand and implement it too. I think we have done with the event, and we appreciate the presence of everyone in this event. So now, thank you everyone. Stay home, stay safe. More on, stay connected with us. And so, ma'am, should I end the meeting formally?
Yes. Thank you, Poonam. Thanks for a wonderful job you have done today. And you can leave.
Thank you, ma'am.
Thank you, everyone.
Okay, thank you,
Thank you,
everyone.
ma'am. Thank you,
I'm
Poonam,
ending
ma'am.
the meeting.
Thank you all.
Thank you, Seema
Thank
ma'am.
you.
Thank you to all of you.
Thank you, Sejwani sir.
Thank you, sir. Thank you very much.